Today we talked about logarithms in Unit 8.3. There were two skills that we discussed today. The first skill was to rewrite an exponential form into logarithmic form. So we want to rewrite 25 equals 5 squared into logarithmic form. There's a basic rule for this that's in the textbook that says if you take y is equal to b to the x power, which you are familiar with because we've studied exponential functions, that we can rewrite this as a logarithmic value, and we write it as the logarithm. B is the base, so we're going to put the log base b of this value y, and that's going to equal the exponent x. So this is your basic rule for converting from either exponential form to logarithmic form or vice versa, logarithmic form to exponential form. So we're going to take this 25 equals 5 squared and rewrite that into logarithmic form. So that would simply be the logarithm with a base of 5, because this is the base, of 25, and that equals 2 the power. That's it. So skill number one is convert from exponential form to logarithmic form. Another problem. 729 is equal to 3 to the 6th power. So the log of base 3, logarithm base 3 of 729 is equal to 3. So look at this one. Deal with a fraction. 1/8 is equal to 1/2 cubed. So the base is 1/2. So I write the log base 1/2 of 1/8, and that equals the exponent is 3. Okay, the second skill that we worked on today was to evaluate logarithms. So what that means is if I give you a basic logarithm, such as log base 8 of 16, and I want to evaluate that and find the value of it, I'm going to set this equal to a variable. I don't care what variable you want to use, y, x, it doesn't matter. So I'm going to set this equal to a variable, x. And now it's in logarithmic form like up here, so I'm going to convert this into exponential form. So the base is 8, so 8 to the x power is equal to 16. So we know that 8 to the first power is 8. 8 squared is 64, so my answer has to be someplace between 1 and 2. So when I look at these numbers, I look at base 8. And I can actually base this number down and write it as 2 cubed. That's 8. And to the x power, so just put the x there, equals, when I base 16 down, that'd be 2 to the 4th power. So that's your goal, is to get like bases here. And if the bases are equal, then the exponents have to be equal. So I just simply write 3x has to equal 4, and then solve that equation. X is equal to 4/3. So if you tried on your calculator and you took 8 to the 4/3 power, that would give you 16. So the log base 8 of 16 is 4/3. Let's take another one. I'm going to evaluate log base 9 of 27. Okay, so I set it equal to x. Write it in exponential form. The base is 9, so 9 to the x power is equal to 27. 9 and 27 have the same base of 3, so 9 is 3 squared. That's 9, and then to the x power is equal to 27 is 3 cubed. And when the bases are equal, then the exponents are equal, so 2x is equal to 3, so x is equal to 3/2. If I take one more problem, log base 64 of 1/32, I'm going to set that equal to x. I'm going to write exponential form, so 64 to the x power is equal to 1 over 32. Now what I don't like about this is this fraction, so I'm going to get rid of the fraction. So 64 to the x power is equal to 32 to the negative 1 power, so we learned negative exponents. So that 32, 1 over 32 is 32 to the negative 1 power. 64 and 32 have the same base number of 2, so 2 to the 6th power is 64, and then the x is still there, equals 32, which is 2 to the 5th power. So 2 to the 5th power, and the negative 1 times the 5 is going to be negative 5. That gives me the same bases. So if the bases are equal, the exponents are, so 6x equals 2 to the negative 5th power. Equals negative 5. So 6x equals negative 5. Solve that, x is equal to negative 5 over 6. And that's it today. Those are the two skills that we learned today.